Hello, class. Last time we talked about the general concept of global warming. In today's class, we are going to focus on the natural system around climate change.
Let's look at part 1, the relationship between natural system and climate. What are the two drivers of climate change?
To understand how the natural system affects the climate, we need to know the concept of driver, which refers to what initiates the change or what breaks the original balance of the system. If we see climate change as an enlarging water balloon, the driver is like the water that runs into it. Now pause for a second and think about what can be a significant driver of climate change. You may list a few examples and see if you are right. As mentioned in the last video, the main driver of climate change are greenhouse gas and aerosol emissions. Greenhouse gas is primarily responsible for the warming effects of the climate. They are like earth jackets. Greenhouse gas includes carbon dioxide, methane, and nitrous oxide. Since the Industrial Revolution, burning fossil fuels such as coal, oil, and gas have increased the concentration of carbon dioxide in the atmosphere, raising from 280 parts per million to 393 parts per million, which far exceed the natural CO2 emission. More CO2 means more heat being trapped, and that's the reason why we're getting warmer and warmer. But is greenhouse gases always bad? Actually, our temperate and warm climate is mainly the result of greenhouse effect. Without greenhouse gases, Earth would be like Mars, where we couldn't even exist. Another driver is the aerosols in the atmosphere that are responsible for both warming and cooling effects. Aerosols are microscopic, solid or liquid particles that are so small that they remain suspended in the air for days to weeks. Human activities like burning biomass or volcano activities contribute to the emission of these particles. Most of the lighter color aerosols are for cooling. They reflect the sun's energy back into space and decrease the heat entering the atmosphere. Darker aerosols, on the other hand, boost the warming effect. Soot, also known as black carbon emitted by diesel vehicles, is a major contributor of dark aerosols. Now we have explained two kinds of significant drivers that initiate climate change. Can you think of some other examples of greenhouse gas emissions that are a result of human activities?
Let's look at part 2, system mechanism in climate change. How do the two drivers impact our climate? Our planet absorbs energy from the sunlight to gain heat, just like how we take a sun bath. When the sunlight's heat reaches Earth, aerosols in the atmosphere, like umbrella and sunscreen, block and absorb part of the radiation, and thereby reduce the total amount of heat that enters our atmosphere. But some heat can still passes through and reaches the ground. The ground absorbs the energy and reflects part of it back. Greenhouse gas can inhibit this process, locking some of the reflected heat inside and increase the temperature. However, the concentration of greenhouse gas has drastically increased, which breaks the original balance of the system, making the Earth too warm.
Now, think about the importance of atmosphere and the energy circulation. What will happen if we have a thinner atmosphere or significantly fewer greenhouse gases inside?
Part 3, the complex interaction in natural system. What are other factors contributing to climate change? With the natural system in mind, the speed of global warming or climate breakdown is actually a collective consequence resulting from various incremental chain reactions within this complex system.
If the climate drivers break the original balance of the system, then climate feedback is the process that can either amplify or diminish these effects of climate forcing. It's like the faucet that controls the speed of the water entering the balloon. For example, clouds, as a slowing factor, reflects about 1/3 of the total amount of sunlight that hits the Earth's atmosphere back into space. A warmer climate would cause more water to be held in the atmosphere, leading to an increase in cloudiness and altering the amount of sunlight that reaches the surface of the Earth. As a result, less heat would get absorbed, slowing down the increased warming. Natural processes, like tree growth, remove about half of human carbon dioxide emissions from the atmosphere every year. This climate feedback used to maintain the CO2 level presented in the atmosphere. However, there is some evidence showing that the ability of the forest to continue absorbing carbon dioxide may decline because plantations are diminishing by worsened droughts, warmer temperature, and deforestation. Therefore, CO2 accumulates faster in the atmosphere due to the declined natural capacity to absorb CO2. Another interesting, fascinating factor is ice albedo. Ice is white and very reflective, and it can reduce Earth's surface temperature. Ocean surface, on the other hand, are darker and absorbs heat faster. So as the atmosphere warms, ice breaks down. Darker ocean now is exposed under the sun. Darker ocean absorbs more heat, so it can raise Earth's surface temperature. Under a higher temperature, more ice will melt, which exposes more ocean. So it's a really strong positive feedback loop that magnifies the warming effect really quickly. Could you name some more examples of climate feedback in our city? Different incremental changes would keep attacking the system equilibrium. Therefore, we will eventually reach a tipping point when small changes become significant enough to cause a larger, more critical change that can be abrupt, irreversible, and lead to cascading effects. It is the point at which there's too much water and the water balloon explodes. If we lose too much ice due to warmer temperature, we will reach a point when we can't reverse the impacts of climate change, no matter what we do. Ice's capability to remain cold largely contributes to its heat-reflecting effects. If too much ice is lost, the Arctic ice would be dotted with dark spots of ocean surface that absorb heat, significantly diminish the heat-reflecting effects. Therefore, the water would be warmer and warmer, and more ice would be lost due to the strong feedback loop of ice albedo. With this vicious cycle in place, ice could not recover to its previous summertime level. As a result, the Greenland ice sheet and the West Antarctic ice sheet would go into irreversible collapse between just 0.8 to 3.2 degrees of warming. As a result, the Greenland ice sheet and the West Antarctic ice sheet would go into irreversible collapse between 0.8 degree and 3.2 degrees of warming. The Arctic Ocean is like a freezer for Earth. If ice is gone, global temperature would rise faster without enough natural mechanism to cool it back down. Arctic summer sea ice could disappear as early as the loss of permafrost is another tipping point. Permafrost is ground that remains frozen for 2 or more consecutive years and contains plants and animals which once inhabited the earth. When permafrost is frozen, the plant material in the soil cannot decompose or rot away. As permafrost thaws, microbes begin decomposing this material, releasing carbon dioxide and methane into the air, which only triggers more warming. The real problem is, once these greenhouse gases are in the atmosphere, we can't really freeze them back in. 1,400 billion tons of carbon are thought to be frozen. 1,400 billion tons of carbon are thought to be frozen in the Arctic permafrost, which is twice the amount of carbon that currently exists in the atmosphere. According to one report, 2 degrees of warming could mean the loss of 40% of the world's permafrost. Seeing all the catastrophic consequences of reaching climate tipping points, it is wise to bend down the global temperature curve and prevent such a future. Current policies put us on pace for roughly 3 degrees Celsius of warming by 2100s. However, research indicates that if we do not curb our carbon emission immediately to keep global warming below 2 degrees, we're headed for irreversible and catastrophic conditions. There is more to be done, and you can help.